Hello, welcome back. I'm Andreas, your tech-curious web designer. In this video, we will deploy our dockerized Django application to a web server. Additionally, we will publish our Docker image to our online container registry and also set up a GitHub workflow to build and publish this image automatically when we push new code to GitHub. But before we get started, a quick shout out to my new supporters on Patreon. A high five to YZ and a fist bump to Begley. Thank you so much for your support. And also thanks to all of you for the coffees on buymeacoffee.com. I really appreciate them and they keep me going. Okay, and now without further ado, buckle up, we have got a lot to cover. First, a quick overview of what we're going to do in this video. We start by preparing our Django application for deployment with the parts relevant for this tutorial. For a more comprehensive deployment guide, check out this video. You will find a link in the description below. Then we will push our code to a GitHub repository and connect it to a web server. The web server, in my case Railway, will build a Docker image from the provided Docker file and deploy the application. After this, we will see how we can publish a Docker image and deploy that to production. For this, we push our local Docker image to an online container registry. I will be using GitHub packages for this and connect it to the web server. We will also see how we can automate the creation and publishing of Docker images on the fly using Github Actions. And finally, we will see how somebody can pull the image from the registry and run it locally. Okay, let's get to it. So we finalized the dockerized application in the last video. And this application comprises 6 Docker containers, enabling background tasks to be run with Celery. And is using our custom Django app image and 2 database images pulled from the Docker Hub. Okay, let's prepare this application now for production. So first I install gUnicorn as the run server in production. Then I install white noise to display static images. We also have to add the white noise middleware. So we go to our core folder, settings.py, and add the white noise middleware. Then we also define the static root. So I add this to our static files configurations here. Okay, and save this file. And finally, I run the collect static command. With python manage.py collect static. This created now the static files folder. We can also add this collect static command to our Docker file. So when a new Docker image is created on the web server, it will run this command automatically. So let's go to our Docker file. And here after copy, I run this command. And to complete this file, I will add in again the default start command. But this is optional, as we add the custom start commands on the server. Alright, save this file. Next, let's set up the environment variables. For this, I'm installing the environ package. So pip install django-environ. Then I'm adding the configuration to my settings.py file. So here at the very top, I import environ and read from the env file. So let's create this file in the core folder, .env, and I define here my local development environment. On the web server, I will change this to production. Okay, save this file. And then I'm fetching this environment variable and also give it a default value, not to raise an error when no env file is found. Okay. Next, I add a toggle for the debug mode depending on the environment. In development, debug is true, and in production is false. Okay. Next, let's set up the secret key. For the secret key, I generate a new one. So in my terminal, I write Python to access the Python shell. Then from django.core.management.utils, I import the getRandomSecretKey function. Then I call this function and print it in the console. And here we have our new secret key. All right. Then we can exit the shell with exit. And then fetch the secret key. Okay. Next, we set up the Postgres and Redis database. So this is my local Postgres connection running inside the container. I connect to this in development. I also add here my local salary broker URL. And here I'm adding now the connections to my remote services. And to connect to the remote database, I will be using a database URL. So let's import the database URL package with pip install dj-database-url. Then I import this package and configure the database. And for this, we create now our Postgres database on the web server. I am using Railway because I have an account there with a hobby plan. The setup might slightly change depending which web server you are using, but the basic concept should be very similar. I just want to point out some limitations when trying to deploy a published Docker image on Railway. However, this might change in future. So Railway does not support a Docker Compose file as for now. That means we have to set up the services manually. You need a pro account to publish a private Docker image. And Railway does not automatically update the image on the server when there is a new version in the registry. We will see all of this later on. Okay, that said, let's carry on. I create here a new project. And first I deploy a Postgres database. And also Railway is deploying this database using a Docker image from the Docker Hub. And now under variables, I can grab the database public URL here. So I copy the value and add it in here. All right. Now the same with the Redis URL. First I change the name of this project. So in settings, I call this project Docker tutorial. Okay. And now I create a Redis instance. So under database, add Redis. Then I click on Redis. Then the variables. And copy the value of Redis public URL. All right. Save this file. And add the salary configuration connecting to this new Redis database. Okay. So let's migrate our tables now to this remote Postgres database. For this, I'm switching now my environment to production so that I'm connected to the remote database and I can do the migrations. So with Python manage.py migrate. It is creating the tables now. Then we can also create a super user. Python manage.py create super user. Okay, super user is created. And with this, we set up the most relevant parts for production. Now let's test this up with those production settings first locally. For this, I first make sure that the containers have access to the environment variables. So I'm going to my Docker Compose file. And the volumes attribute does this already by copying the env file to the container. We can, however, explicitly specify where our env file is located using the env_file attribute. And our env file is stored inside the core folder. Let's add now this attribute to all the services which use the my app image, celery, flower for sure, as we did not add the volumes here, and to Pete. Okay, save this file. Next, let's add all the new packages to the requirements.txt file with pip freeze. Then I create a new image with Docker Compose build. And now let's redeploy our containers using this new Docker image with Docker Compose app-d. So this is recreating our containers now. The containers are using now the latest app image, so we can delete the old one. Alright. And all our containers are up and running. Let's check it out. And great, this is now our Django application running locally in the production environment. And we can test this simply by going to our 404 page to check if debug is off. Let's also check the admin interface, if Postgres is connected, and if the static images are loaded. And yes, I'm logged in here in the remote Postgres database. Nice. So all looks good for production now. Let's switch the environment back to development. And save. Okay, next let's push this application to a GitHub repository. So here I connected now my project to GitHub Desktop and I publish it on GitHub. If you're not familiar yet with GitHub and GitHub Desktop, you'll find more information in my deploy video. I call this repository on GitHub Docker tutorial and publish repository. Okay, let's connect this GitHub repository now to our web server. So here first I'm setting up my environment variables, and I can set up shared variables so I can share them between all my services. For this I'm going to settings, shared variables. Then I click here the curly brackets and copy and paste in all my environment variables. But I set the environment here to production. Okay, and update variables. Then I deploy them. Alright, and now I add my Django application. So I create a new service for my GitHub repository. The name of my repo is Docker tutorial. We can rename the service to app. Then I add my variables, shared variables, and add all. And in settings, we can see my source repo is my GitHub repository. We will change this later to pull a published Docker image. And under deploy, I add my custom start command, which is using gunicorn. Okay, then we click deploy. We can check the logs. And as we can see here, Railway detected the Docker file in the project and is building and publishing the image now. And here we can see the steps or layers it is going through. Okay, it deployed now successfully, but we have not exposed it yet to the internet. For this we need to generate a domain. Under networking, I generate a domain. So this is my domain. Let's copy it and add it to my allowed hosts in my settings.py file. And also to the trusted origins. Okay, save this file and push the code again to GitHub. It is rebuilding the image again automatically. And once this is deployed, we can check out the website. And the site is up and running. Let's log in. And we're connected to our Postgres database. Excellent! Next, let's take a look how we can deploy this app directly from a Docker image. To do this, we need to publish our Docker image to a container registry. The go-to registry for Docker images is obviously Docker Hub. Another popular place is GitHub's Container Registry. This is a good solution if you want to store all your code in one location, and we combine it with Github Actions to create a workflow to build Docker images automatically. We can find our published Docker images here on GitHub under the Packages tab. And here we can find the Containers Registry, which is abbreviated as GHCR, GitHub Container Registry. In order to be able to publish a Docker image to this registry, we need to create a personal access token. To create this token, we go to our profile here, then to Settings. Here on the left side, we go to Developer Settings. Then here under Personal Access Token, we choose Tokens Classic. And then Generate New Token. And again, Generate New Token for general use. I give this token a name. Docker Image Token. Then we can add an expiration date for this token. This is just making it more secure. And then in the Select Scope section, we need to select Write Packages and Delete Packages. Okay, and then we create a token. So this token gives us now access to the registry. We will need this token again later on, so best save it somewhere. Okay, let's create the connection now to this registry so we can publish our image. So in the terminal, I write docker login, then I'm writing the service I'm using, the GitHub Container Registry, then we add the username of the GitHub account, in my case Andy Judd, and then we add the password. And here we paste in the access token we just generated. So I copy this token here and add it in here. Okay, enter. So we get a warning here that passing the token directly in the CLI is insecure. However, we do it here on our local machine, so we can ignore this. And now I create a new Docker image of my application, but this has to follow a certain naming convention. So docker build and dot, and with -t I'm tagging this image. And first here I have to write the service I'm using. So GitHub Container Registry.io / then the username, And then the name I want to give this Docker image. My app image. Like that. And enter. So this created now a new Docker image. Let's check it out. If you go to images here, we can see it created this new image. Okay, and this is the image we published to the registry now. We can also see this image when we type Docker images. So I copy the name now and publish it with Docker push. And then the name of the image. Okay, this published now the Docker image to the registry. Let's check it out. And as we can see, we have now the Docker image published inside the GitHub packages. We can also connect it to our repository. And if we do that, the README file of the repository is displayed here. Alright, and now let's deploy the app directly from this image. By default, this image is private. However, to deploy a private image on the Railway, we would need to have a pro account there. Otherwise, we will need to make this image public. For this, I'm going to Package Settings and change here Visibility to public. Alright, then let's copy the name here, go to Railway, then into my app, in Settings, I disconnect from my GitHub repository, and then I connect to the Docker image instead. So here I add the name of the image published on GitHub, and I click Deploy. And once it is deployed, we test the website. I refresh the page, and the website is up and running, but now connected to a Docker image stored on a registry. Nice!
Nice.
However, as mentioned before, if we change the code and create a new Docker image, this is not automatically updated on Railway, and we need to update it manually. Let's have a brief look at this workflow, and also build the Docker image automatically with Github Actions. For this, I will make a small change in the code, like changing the header color of the navigation bar. So I'm going to my header.html file in the templates folder, to includes, to header, and change this color to blue. Okay. And now instead of manually creating this image, I will create a workflow with Github Actions, which will create a new Docker image whenever I push new code to the GitHub repository. So in my root, I create a new folder called .github, and within this folder I create another folder called workflows, and then I create the actions file in YAML format, and I call this file docker-images.yaml. So in this file, I will write instructions to GitHub when and how to create a new Docker image. So I give it a name, publish Docker image. I want this image to be created on every push to the GitHub repository. Then I add here the jobs. We have only one job, and this is to build and publish the Docker image. So I call this job build and publish. Runs on defines the operating system that the job should run on, and Ubuntu latest is the standard. And then I add here the steps. Then first we use the checkout action, which checks out our repository code. And we're using version 4 here, which is the latest version as for now. You can see the latest version in the GitHub Marketplace. Here we can see the latest version available. And the second step is to build and push this new Docker image. I give this step a name. Then I'm running here the commands. And with the pipe symbol, I can run multiple commands sequentially within the same step. So the first command is the login command. Here again the service I'm using, the username, and the password. However, we should not expose the personal access token here. Rather, we can save it in a secret and add it back in here using a variable. So let's copy this string, go back to GitHub. Then we go to our repository. Then here to settings. Then here to secrets and variables. Then select here actions. And here we can create a new repository secret. I give it a name, my personal access token, and add this token in here. Then click Add Secret. Okay, and now we can use this variable in our command. And this is how we import the variable from the secrets. This command will give us access to the registry. Next, we build the Docker image and give it my app image name. And lastly, we push the image to the registry. Alright, that's it. Okay, save this file and let's check it out. We push the changes to the GitHub repository. So here we have the workflow definition. And we also have the color change in the navigation bar. I call this commit workflow and push to GitHub. And here, if we inspect the Action tab, we can see the process of creating the Docker image. Okay, now the Docker image is published, let's check it out. We can see that this image was published less than a minute ago, and now let's redeploy it on the web server. So here I go to deployments and redeploy. Sometimes this doesn't work, so in that case, just disconnect and reconnect the Docker image again. Let's refresh the page. And the new code is live. Great! As we just have seen, deploying from a Docker image on Railway requires manual deployment. Other web services might offer this with automation. But this is not really ideal for our main application, which might receive code updates regularly. However, for the other services in our Celery ecosystem, which do not require to be rebuilt every time there's a new code change, this could be a great solution. Let's deploy now also the other services using the Docker image. I create an empty service, rename it to Celery Worker, add the shared variables, connect the Docker image, add the Celery start command, and deploy the service. Okay, and now let's run a background task to see if our Celery worker works. So I inspect the logs, go to my website, and click Count to 10. And as we can see here, the task has run successfully. Next, I add flower. Add the variables. Connect the image. Add the flower start command. And deploy the service. And finally, also generate a domain to expose it to the web. Okay, let's check it out. And we have our flower interface up and running. Let's test this. We can see we have one active task right now. And it took 10 seconds to run. Alright. And the last service we add is Beat. I change the title, add the variables, connect to the image, add the beat start command, and deploy. Okay, let's test also beat. So I'm going to my admin interface, select periodic tasks, create a new task. I name it send newsletter. And schedule it. Okay, let's check it out. And as we can see, also the schedule task runs successfully. Alright, now our whole Celery ecosystem is deployed to the web server using a Docker image. As last, I want to demonstrate how to pull this Docker image and run it locally. For this, I first delete all my local containers and images. I delete all my containers. And all my images. I have here a new empty folder called Docker pull, and I'm pulling here now my Docker image. So I copy here the pull command, and download the image. Now we have this new image on our machine. Now let's add the Docker Compose file to run the containers. I grab the code from my GitHub repository and create now this Docker Compose YAML file. And paste the code. Here we get rid of the build command because we got the image already. And we also get rid of the volumes because we have an empty root folder and nothing to sync. I delete the volumes also in the Celery container and in Beat. And lastly, I also have to change the name of the image to just my app image. And I can do this with the docker tag command. Then the name of the image we downloaded. And then the name I want to change it to, which is my app image. Okay, this created now a new image with that tag. And we also have to create the entrypoint.sh file for our app service. So let's create this file. Grab the code and paste them in here. This file needs to be executable, so we run the change mode command. This added now the execute permission to all classes. And now finally we can run the containers with docker compose up-d. Alright, all the containers are created. And as we can see, all of them are up and running. And we have the website running locally from a Docker image. Alright, with that we finished now this Docker tutorial series. And you should have now a good grasp how Docker works. Thank you so much for watching, and I hope to see you very soon. Until then, stay curious my friends, and bye bye for now.